Did you know Megalodon's bite force was strong enough to crush a whale's spine in seconds? For years, we've been amazed by stories of Megalodon's huge size and deadly hunting skills. But what does the latest research tell us about this ocean giant? Imagine a creature so big and powerful that it ruled the oceans millions of years ago. This was the Megalodon, an apex predator whose size and strength still surprise us today. But what if everything you thought you knew about this giant shark was wrong? What if secrets about it are still hidden deep in the ocean? How much of what we believe is true, and how much is just a myth? In this video, I will take you deep into the world of Megalodon. It is one of the most famous and terrifying creatures to ever swim in the oceans. We'll look at the latest discoveries that are changing what we know about this giant shark. We'll also break some popular myths that have kept us curious for years. And we'll reveal new details about why Megalodon vanished from the seas. By the end of this video, we'll uncover the truth about Megalodon's amazing story. We'll explore the science, the myths, and the reasons behind its extinction. So let's dive into the history of the deep oceans and discover the secrets of this ancient giant. In 2024, scientists made an amazing discovery. They found a megalodon tooth deep in the Pacific Ocean, still resting in its original place on the ocean floor. Most fossils are found scattered in shallow seas, but this one gave us a direct glimpse into Megalodon's world. It suggests that Megalodon's behavior was far more complex than we once believed. The tooth was located at a depth much deeper than where we thought Megalodon lived. This discovery raises an important question. Did Megalodon stay in shallow coastal waters, or could it dive into deeper, mysterious parts of the ocean? The depth of this find suggests that Megalodon might have hunted in deep waters. It could have used the ocean's depths as its hunting grounds, going after prey that modern predators rarely reach. This discovery, made during an oceanic expedition, changes what we know about Megalodon's habitat and feeding habits. Scientists have been studying Megalodon fossils, especially teeth, for many years. Each fossil adds more pieces to the puzzle of its life. One of the most exciting findings from these fossils is about Megalodon's diet. Megalodon didn't just eat giant fish or smaller marine animals. Evidence shows that it also hunted large marine mammals, including whales. This variety in its diet shows that Megalodon was an opportunistic feeder. It likely hunted anything that was common in its environment, whether it was slow-moving marine mammals or large fish. Fossil evidence also tells us about Megalodon's habitat. Many people thought it lived only in shallow coastal waters, but fossils found in deeper waters tell a different story. Megalodon seems to have lived in both coastal and open ocean areas. These deeper water fossils show that Megalodon could travel long distances. It also hunted in areas that were once thought to be too deep for it. This proves that Megalodon was very adaptable. It could live and hunt in different marine zones, depending on where prey was available and the conditions of the environment. Our knowledge about Megalodon's diet, behavior, and environment comes from detailed research. Scientists have studied fossilized remains, marine sediments, and isotopes to understand its role in the ecosystem. Institutions like the Smithsonian Marine Science Program have done important work to expand our understanding. Their studies have shown that Megalodon wasn't just a coastal predator. It had a much larger range than we once thought. Recent discoveries, combined with older data, have completely changed how we view Megalodon. It was not just a giant predator in shallow waters. It was a powerful hunter that could thrive in many different parts of the ocean. Every new fossil and every new study helps us understand Megalodon better. These discoveries show that Megalodon was a symbol of power and an adaptable predator. The more we learn, the more we see how this ancient shark dominated the oceans and why it eventually disappeared. The secrets of this ocean giant continue to unfold with each new discovery. The deeper we dive into the past, the closer we get to uncovering the mysteries of Megalodon's incredible life and extinction. For many years, Megalodon was seen as a massive predator, growing up to 60 feet long and weighing over 100 tons. This idea was based on early size estimates taken from modern sharks like the great white. However, a big discovery in 2024 changed how we see Megalodon's body and size. New research using better fossil evidence and advanced tools shows that Megalodon was likely slimmer and more agile. Its real size was closer to 50 feet long, and it weighed around 50 to 70 tons. This is much less than what scientists thought before. A smaller size also means Megalodon needed less energy to survive. Its streamlined body helped it move more efficiently, allowing it to travel longer distances while saving energy. This might have helped it hunt across wide areas of the ocean. These new findings show that Megalodon wasn't just a giant predator. Instead, it was likely fast, smart, and efficient in how it hunted. This makes us wonder more about how it lived and what kinds of prey it chased. When we compare Megalodon to modern sharks, we see big differences. Today's great white sharks can grow up to 20 feet long, but Megalodon's 50 feet length made it more than twice as big. Megalodon also had a strong, heavy body designed for powerful bites, unlike today's sharks that rely on quick speed bursts. Megalodon's body shape suggests it didn't need to move fast in short bursts. Instead, it could follow prey over long distances, using stamina and strength. This hunting style was different from great white sharks, which surprised their prey with sudden attacks. It gets even more interesting when we compare Megalodon to marine predators like orcas and sperm whales. Orcas are smart and hunt in groups using teamwork to catch big prey. Sperm whales, while large and strong, mostly dominate deep water areas. Even with these modern giants, Megalodon was still huge. Sperm whales can grow up to 60 feet, and orcas about 30 feet. But Megalodon at 50 feet still stood out. Yet Megalodon didn't need groups or intelligence to hunt. It relied on its size and strength, hunting alone and attacking big prey like whales. This difference shows how ocean predators have changed over time. Today's top predators depend on teamwork and smart strategies, but Megalodon ruled with power and efficiency. It was a lone hunter, designed for a different kind of ocean life. These new ideas about Megalodon's size and hunting style help us understand it better. We now see it as a predator built for efficiency, not just size. Comparing it to modern predators shows how unique Megalodon was during its time. One of the most persistent myths surrounding Megalodon is the idea that this colossal predator is not truly extinct. Over the years, countless rumors and speculative claims have surfaced, suggesting that Megalodon might still be lurking in the unexplored depths of the ocean, perhaps in some remote corner of the planet that remains beyond human reach. Movies, documentaries, and internet stories have stoked this idea, creating a tantalizing notion that the Megalodon could still be hiding, waiting to resurface. However, when we turn to scientific evidence, the reality is far less exciting. There have been no credible modern sightings of Megalodon, nor has any physical evidence been found that supports its continued existence. No Megalodon teeth or other fossils have been discovered in recent years to suggest that the species is still alive. Perhaps more importantly, there is no DNA evidence, which is a key factor in confirming the presence of any large animal. Given the size of Megalodon and the vastness of the oceans, it's unlikely that such a large predatory shark could have remained undetected for so long. Moreover, when we examine the ecological viability of Megalodon surviving today, the picture becomes even more improbable. Today's oceans are very different from the ones Megalodon once roamed. Many of its prey species, such as giant whales, have significantly changed in terms of distribution, behavior, and population. With the pressures of modern marine ecosystems and the fact that Megalodon's primary prey would now be much more scarce or harder to catch, it would be extremely difficult for such a large predator to thrive. So, despite the allure of this idea in popular culture, the scientific consensus is clear. Megalodon did not survive into the present day. Another myth that has gained traction over the years is the idea that Megalodon grew to mind-boggling sizes, far exceeding what was physically possible for even such a massive predator. Some exaggerated claims suggest that Megalodon may have reached lengths of up to 100 feet, a size so enormous that it seems more fitting for a creature from a science fiction movie than a real animal that once roamed Earth's oceans. But when we examine the fossil record, particularly the teeth and jaw fossils that are the primary evidence for Megalodon's size, we find a much more grounded reality. While it's true that Megalodon was an enormous shark, reaching lengths of up to 50 feet, the notion that it grew beyond 100 feet is simply unfounded. Detailed analysis of its teeth, combined with advanced modeling techniques, shows that Megalodon's maximum size was likely around 50 feet, with some individuals perhaps reaching up to 60 feet in exceptional cases. The larger-than-life figures we often hear about simply don't align with the scientific evidence. These inflated size estimates were likely the result of miscalculations and sensationalist reporting rather than any substantial scientific findings. It's easy to see how the myth grew. Larger size equals greater awe and fear. But in reality, the true size of Megalodon, though massive, was far more reasonable than the exaggerated tales we've come to know in popular culture. The role of media in shaping our perceptions of Megalodon cannot be understated. Sensationalist movies like The Meg, featuring a giant, prehistoric shark wreaking havoc in the modern ocean, have done a tremendous job in turning Megalodon into a mythical creature. These films, along with documentaries and fictional books, have made the Megalodon seem larger than life, often presenting it as a creature far more dangerous and capable than what the scientific record supports. While these stories are fun and exciting, they also perpetuate myths about the shark that can lead to a distorted understanding of its true nature. Films like The Meg exaggerate its size, intelligence, and behavior for entertainment value, but these portrayals are far from the reality that scientists have uncovered. In truth, Megalodon was a powerful predator, but not the unstoppable force that Hollywood often makes it out to be. It was a creature of its time, a product of evolution, and its extinction was due to ecological shifts, not an inability to adapt or survive in a world filled with increasingly dominant predators. It's important to separate fact from fiction when discussing prehistoric creatures like Megalodon. While the idea of an ancient, massive shark still lurking in the ocean is an exciting one, the truth is that the Megalodon was an apex predator of its time, and no amount of media hype can change that. Understanding Megalodon for what it truly was allows us to appreciate its legacy while letting go of the exaggerated myths that continue to surround it. Through debunking these popular myths, we get a clearer, more scientifically accurate picture of Megalodon. From its extinction to its actual size, the myths that surround this fascinating creature often overshadow the reality of its life and legacy. By looking at the facts, we can truly appreciate the power and mystery of Megalodon without the cloud of misinformation. As we dive deeper into the mystery of Megalodon's extinction, one of the most significant factors to consider is climate change. The Pliocene epoch, which spanned from about 5 to 2 million years ago, marked a period of significant cooling in the Earth's climate. This shift in temperature had a profound effect on the oceans. The cooler waters meant that the habitats which Megalodon had once thrived in began to shrink. Megalodon, being a predator of warm, temperate seas, found its range increasingly limited as ocean temperatures dropped. But it wasn't just the changing climate that impacted Megalodon's survival. The cooling waters also contributed to a decline in the populations of Megalodon's primary prey, large marine mammals like whales and other large fish. As these creatures became less abundant, Megalodon faced a double threat: shrinking habitats and a dwindling food supply. For a creature that required massive amounts of food to sustain its size and energy needs, the loss of these vital prey species was catastrophic. The combination of habitat loss and a decline in food availability created a perfect storm for the Megalodon, leading to its eventual extinction. A fascinating new perspective on Megalodon's extinction comes from recent research, particularly from studies conducted at UC Merced, which suggests that Megalodon may have been warm-blooded or endothermic. This insight challenges the long-held belief that Megalodon was cold-blooded like modern sharks. If Megalodon indeed had the ability to regulate its body temperature, it would have needed to consume far more food to sustain its higher metabolism. This is a key factor when considering the challenges Megalodon faced as the environment around it changed. The demands of being warm-blooded would have put even more stress on Megalodon during periods of food scarcity. As the temperature of the oceans cooled and its prey became less abundant, the metabolic needs of a warm-blooded predator like Megalodon would have been difficult to meet. Unlike cold-blooded animals, which can survive on less food because their metabolism slows down with the temperature, warm-blooded animals require a steady and abundant food supply to keep their bodies at optimal functioning levels. This metabolic pressure would have made survival increasingly difficult for Megalodon as the oceans cooled and its food sources dwindled. Another major factor contributing to Megalodon's extinction was the rise of new, more adaptable predators. As the climate changed and the oceans cooled, smaller, faster predators began to thrive. The great white shark, one of Megalodon's most famous competitors, evolved during the late Miocene and early Pliocene. Unlike Megalodon, the great white shark was more agile, required less food, and could survive in a wider range of temperatures. This adaptability gave it a distinct evolutionary advantage over the Megalodon. The great white shark, along with other emerging predators, was able to occupy similar ecological niches as Megalodon, but with a much lower energy demand. While Megalodon relied on massive amounts of food to sustain its size and high metabolic rate, these new predators had the edge in terms of speed, efficiency, and the ability to survive in cooler, less productive waters. This competition for resources would have pushed Megalodon out of the food chain, eventually contributing to its extinction. The survival of these smaller, faster predators and their ability to adapt to changing conditions marked the end of the Megalodon era. Megalodon's extinction wasn't the result of a single event, but rather a combination of factors working together. Climate change, shifting ecosystems, metabolic demands, and the rise of more competitive predators all played a role in the downfall of this once dominant ocean predator. By understanding these factors, we not only gain insights into the life and times of Megalodon, but also learn valuable lessons about the fragility of ecosystems and how even the most powerful creatures can be pushed to the brink of extinction. Megalodon was undoubtedly the apex predator of its time, ruling the oceans with an iron jaw. But how did it hunt and maintain its dominance over such vast territories? Unlike modern sharks that often rely on speed and agility to catch prey, Megalodon likely employed a more strategic approach: ambush. With its massive size, it didn't need to chase prey down at high speeds. Instead, it would have likely ambushed slower-moving animals, such as large whales, catching them off guard. Imagine a giant shark waiting patiently in the deep, using its powerful sense of smell to detect vulnerable prey from miles away, then striking swiftly with terrifying force when the opportunity arose. This hunting strategy was not only about physical power, but also about maintaining balance in the ecosystem. Megalodon played a crucial role in controlling populations of megafauna, including large marine mammals and other prey species. By preying on these massive creatures, Megalodon prevented any one species from becoming overly abundant, ensuring that the marine ecosystem remained in harmony. The extinction of such a predator could have led to overpopulation among prey species, disrupting the delicate balance of the ocean's food chain. Megalodon wasn't just a hunter. It was an integral part of the ecosystem that helped regulate the population of other marine species. For many years, it was believed that Megalodon cruised through the ocean at high speeds, chasing down its prey with the swiftness of modern predators. However, recent structural analyses of its fins and vertebrae have revealed a different story. Evidence suggests that Megalodon was actually a slow cruiser, moving at slower speeds than previously assumed. This finding challenges the earlier belief that its size and speed made it a formidable, fast-moving hunter. Instead, it seems that Megalodon used its sheer size and power, along with stealth and patience, to hunt effectively. The analysis of its body structure shows that Megalodon's fins and tail weren't designed for fast bursts of speed like those of smaller sharks. Instead, its body was built for cruising, allowing it to move steadily through the ocean in search of prey. This slow, methodical hunting style was likely well-suited for ambushing large, slow-moving creatures like whales, which were a major part of Megalodon's diet. While it may not have had the agility of smaller predators, Megalodon's strength, size, and strategy allowed it to rule the seas. The combination of a slow, deliberate hunting style and its role as an apex predator made Megalodon a fearsome force in the ancient oceans. As we reach the end of our deep dive into the world of Megalodon, let's recap what we've uncovered. This legendary predator, once thought to be an unstoppable force of nature, continues to fascinate us with every new discovery. From the groundbreaking 2024 findings that reshaped our understanding of its habitat and behavior, to debunking exaggerated myths about its size and survival, we've pieced together a more accurate picture of this prehistoric giant. We've also explored the secrets of its extinction, how climate change, competition, and ecological shifts sealed its fate, and delved into its crucial role in balancing ancient marine ecosystems. Each new insight into Megalodon not only reveals its extraordinary past, but also reminds us of the delicate balance that defines life in the oceans. Though the Megalodon vanished millions of years ago, its legacy endures. Its story, still unfolding with each discovery, is a testament to the mysteries that lie beneath the ocean's surface, a world we've only just begun to understand. If you've enjoyed uncovering the secrets of Megalodon, don't forget to like this video, share it with fellow enthusiasts, and subscribe for more fascinating stories from the prehistoric world. What do you think was Megalodon's greatest strength? Let us know in the comments. And for our next adventure, we'll be diving into the evolution of prehistoric sharks into today's oceanic predators. Stay tuned.